All right, so this set of presentation slides, originally written by Xiaorui, and I added a couple things. Okay, so RMG comes with a bunch of tools. Why do we need them? They help us analyze the model, and I think or hope one takeaway message from this workshop should be that running RMG is really just the very beginning, and there's a lot of work that goes on after that. And so these tools help you ask a lot of questions like why, and especially what if. Like, what if this thermo was a little bit different, or things like that. So there are a bunch of scripts. Some of them are just Python scripts, these .py files, whereas the Jupyter notebooks they tend to come in different categories, not because Jupyter notebook or Python script like inherently you could run the code in either one, but in general we found that the .py files it's easier to run them for a longer time, and then for the Jupyter notebooks, they usually have shorter running time, but they're more interactive, and they often make use of the RMG API, so they can be a little bit more advanced, but also maybe a little harder to understand, whereas the .py scripts are sort of just cookie cutter, use them, and you don't really have to understand how they work. Okay, so I'm going to go ahead and oh yeah, we've got a slide on how you run them. Most of the scripts that are the .py ones, they're just Python, the name of the script, and then your arguments. But there's an examples folder in the RMG repository that I'll show you that shows you how to use every single one. Oh, sorry. There we go. Okay. All right, so we're going to go ahead and very briefly, I'll show you some of these. So the first one is generate the HTML. And so where should I do this? How about here? I'm going to go ahead and use my Windows subsystem Linux here. So I'm going to go into the RMG Py folder, and then there's an examples folder. And instead of RMG, because we're not going to run RMG, we're going to use the scripts examples. And so we're going to first do the generate HTML. Nope, that's not it. Generate Kempkin HTML. Okay, so you can see I've already run this, but what you start out with is this run.sh. And so if we look inside, it just has the command for running the generate Kempkin HTML Py tool. And so you can, oh, it happened again. It's the, oh, that's another way. You can cat, the command cat will print out the contents of a file. So I can just run the run script with the command bash run.sh. And so what this is going to do is generate the output HTML. And when you're running scripts on bash, typically if it doesn't say anything, it's a successful run. So now we're going to go ahead and look at, we'll do it here. Actually, here, I'll go this way. So now we can take a look at the HTML report, and this is the same one that I showed this morning, or a similar type where it shows you all the species and all the reactions. So that's one tool. If you haven't, while you were running RMG, you didn't generate it, you can generate it after the fact. The second tool, this is a really useful one, is diff models. So if you've got two different models that are supposed to be simulating the same chemistry, but maybe one of them uses a library that has a lot more DFT than another one, you could compare the two. And that's what this diff models example does. Once again, I've already run it, but you would bash example.sh would run it. We can see the contents in here. It's a little bit more involved. So, sorry, these are commented out. It's only running this. So it's doing Python, and then it runs the script that calculates the diff, and then this script needs as arguments it needs the two different models. So one of them is called DFT Chem, and it's got an associated dictionary. And then the other one is called Primary Chem, as in the primary thermo library, and it also has an associated dictionary. And so what you do then, once you've generated that, you can look at the report that it comes out with. So here we've got a diff report that shows you what's the same and what's different. So for example, if two species like argon in one model and the other, if they have exactly identical thermo, then you get the blue. This blue font or color. Green is for similar, but maybe not exactly identical. And then red if they differ by a significant amount. And then it does the same thing for the reactions. If we scroll down to the bottom, so you get a similar report for what's the same and what's different. And then if you go all the way to the very bottom, it'll also tell you what is unique from one model to the other. And so in this one, model 1, I believe, has the DFT library, and it found a whole bunch of other reactions. And then same thing with, it's tricky to find it, but it also has the unique species. That's right here. Yeah, so the one with DFT came up with extra species. Okay, so next up on our list of useful RMG tools, we've got generate flux diagram. Flux diagrams are a favorite of mine. I think they're really helpful for visualizing. And
filling out posters.
Yeah, they're so good for posters and presentations and. All right, I actually haven't practiced this one on this particular RMG environment, so this might work, it might not. Either way, it's probably going to take a few minutes, so, well, maybe not. We can see if it's generating it over here. So generate flux diagram. If we go into this flux reactor 1 thing, it looks like it's generating them. It doesn't, I don't know if it'll have worked. Okay, so it generates these images, and you'll notice that I'm scrolling, and it's supposed to be advancing the time, and it is. Oh, that's what's happening. It's creating the time steps at the beginning are really small, and so you got to go way down to the end to see. Here we finally got time is advanced to 10 to the negative 4th, and you can start to see the arrows. I don't know if this comes across. It might not. Oh, you can zoom in. There we go. I can zoom in and there we go. Sorry, it's easier to see. You can do sort of a quasi video on your own, like in your own viewer. It does generate a video too, I believe, at the end, so you can see the evolution of how it creates certain species at the very beginning and others only at the end. Let's see if it created the video file. I don't know if this example does or does not. Oh, yeah. So nothing's happening for many frames, and then it starts to happen. It happens slowly. You can change the frame rate to make it happen faster. There's 15 seconds left. 15 exciting seconds. All right, so yeah, this is a very helpful tool for seeing how, visualizing how your reactor reacts. Just one thing worth mentioning is that these flux diagrams are only implemented for a single time, pressure, mole fraction condition. And so if you want to, you have to specify that in the input file. And if you specified like a range reactor, you'll have to modify that for this tool to be able to limit it to a single temperature and stuff. Okay, we're almost through the ones that I wanted to cover for this. Merge models, I'm only going to talk about this. This is helpful for if you've got two separate mechanisms and you want to combine them into one. You can run this merge models example. It will, one thing to note is that it will prioritize the first model that comes in the as the argument. And so if you've got like one that you trust more than the other, you definitely want to list it first, because once it finds a species thermo in model 1, and if it finds the same thing in model 2, it's just going to discard the kinetics because it already has it. Simulate is if you it's just another if you already did we looked through this with the solver example, so it simulates the mechanism in RMG's here we go, yeah. It will run the simulation of your input file given the reactor conditions and make the plot for you. So I don't know if that relates to the earlier question of you don't necessarily have to write Cantera code to see a simulation plot, but you don't have as much control. This is just a very simple batch reactor, so it's not you can't control like the mass flow rate or the reactor geometry. But one thing, I have mixed feelings about whether to show this, because the sensitivities are probably better done or they're more quickly or more thoroughly done. Sorry, that's the wrong one. The sensitivity. You can see which these are reaction rates, which are the most sensitive in this ethane pyrolysis mechanism. So it can also compute the sensitivity inside this example. Let's see, where's generate reactions. I skipped over this one. This is if you wanted to see all the possible combinations of species that you could get, or all the reactions that you can make using a set of input species, you can run this, and it's basically the equivalent of running a single loop of RMG, or just enumerating all the possibilities, but without iteratively adding more and more things. And then there's also, I'll do a thermo estimator. So once again, if we wanted to run this example, thermo estimator, it would be bash run.sh, and that's the contents of this, it's running Python and then our thermo estimator script, and then you give it the input file. So this is saying if I wanted to estimate the thermo for a given set of species, where are we? Keep doing this. Here we are. Oh, input.py. Okay, so it gives the input file is just a bunch of species here, and you can give it the thermo database, and it will give you an estimate for all of those species. And what that looks like then after you've run it is an output Chemkin file, which you can open in Visual Studio Code, and this will give us our thermo estimates for the input species. So you can see here the same species that were in the input file, and here are all their NASA polynomials, and you can see here are all the groups. In the comment, it shows which groups were used to estimate it, or if you had specified libraries in the input file, it would probably show some libraries. All right, so one final thing I wanted to show you. These are, just very quickly mention, there's a script for exporting a kinetics library to a Chemkin file. So if you've got something that is in the RMG library format and you want to use it as a Chemkin mechanism, this is what this is for. And then you can go kind of in the opposite direction. If you've got a Chemkin model and you want to load it into the database, then you would run this import Chemkin library to go from Chemkin model to RMG format. So just one more time, this one, the export kinetics library, that's RMG format to Chemkin, whereas this one is going Chemkin to RMG format. All right, so last thing I wanted to mention is that, so those are just a handful of scripts that exist in the RMG repo, but as RMG developers, ultimately you'll end up making scripts for yourself, and also the wider community of RMG developers have built a bunch of random scripts over the years, and if you talk to people and look at their forks of RMG and their repositories, you can find a number of cool tools in there. And so one I'll show you is I made a a comparative flux diagram. And so there's a link here. It's on my fork of RMG Pi. And so what this does is you can make those same videos of the flux diagram, except instead of this is currently a branch, the comparative flux diagram, where you can generate the same sort of video type thing where you go and this is comparing. This was the model diff that we did earlier. The blue is the mechanism that uses the RMG primary thermal library, and then orange is the one with extra DFT. And you can see as it evolves, it's mostly the same until the very end. You end up with more of these radical species that it didn't discover these in the diff model, which if I've still got open, you can see this. This is a unique species. It didn't find it if it only the library with DFT was able to find this method. And so that just goes back to emphasize the point that figuring out the core thermochemistry and getting good values for your most important species is important to filling out the model. And so it really is an iterative process. You won't know ahead of time necessarily what the best things are to include in your model. And so running RMG, analyzing it, improving the parameters is how you get everything that you want and need. All right, so one final note on that. I've said final like 40 times already. Okay, so so yeah, if you want to learn more about the RMG tools, definitely check out the website. There's the IPython notebooks and the example folders. Try the examples and try making your own and see what you get.